next problem is called generate parentheses. We are given n pairs of parentheses, and we have to write a function that generates all combinations of well-performed parentheses. So, for example, if we have n equal to 1, the only correct pair would be one open bracket and then immediately a closing bracket. For the n larger n, for example 3, we will have five different combinations of well-performed parentheses. As you can see, all of the parentheses are if we have an open parenthesis, we will always have the matching closing parentheses, and that goes for all of the parentheses inside the combinations. Now, for the not well-formed, like invalid combination of parentheses, we can quickly notice that if we have one open bracket, one open parenthesis, and if we have two closing, no matter what we have after this, this can no longer be a valid well-formed parentheses, because there will be no matching opening bracket for this one. So you can see that we always have to have on the left side, when we look, we always have to have at most same number of left opening parentheses and right closing parentheses. In most of the cases, we will have more left opening parentheses than right, and then in the remainder of the combination, we will have the remaining closing brackets, so we can have a well-formed parentheses. That's the first trick. That's the first hint that we have to solve this to solve the problem. The next thing to notice that if we have n equal 3, we will have a pair of parentheses. So it's not that we'll have in total 3 parentheses, we will have in total 6 parentheses. So a valid combination will have 3 open, 3 left parentheses, and 3 closing right parentheses. So that's the second thing that we need, because this will help us form our base case in the recursion. And when you see this generate, it should immediately point you to there's something going on with the with like calling the function several times, having a recursion tree, and then backtracking, checking if the combination is valid, adding the current candidates, and so on. So this should like be your first hint. Now, if you go to an example, we will go through an example of n equal to 2, and we will see how we are forming the recursion tree. So we will be passing the 3 important parameters to the recursion function, and that will be our current combination that we are generating, the total number of left parentheses, and the total number of right parentheses. We will also have the list of valid combination to which we will be adding the current combination. But for this example, that's not so important. So if we have n equal to 2, we will start our call by initializing an empty string, and for the left parentheses we will have 2, and for the right we will have basically the same. So that will be the start of our recursion tree. Now, the first thing that we had, the first rule, is that we should always have we can only use the right parentheses if we have already used more left parentheses. So if you have used only one left parentheses, we cannot use 2 right parentheses in a sequence. We cannot do that. But if we have, for example, 2 left, we can use the following bracket can be the right one, because in this case right is larger than left, which basically means that we have more right brackets to use than the left. So basically we will be going deep down into recursion tree as long as we have left parentheses to use, because we know that the well-formed parentheses will always have more left parentheses on the kind of left side, followed by the right parentheses on the right side to form a well-formed parentheses. So we will start with an empty string. We have in total 2 left parentheses and 2 right parentheses. and our first branch will use the left parentheses. It will add the left parenthesis to the current string, and it will decrement the left parenthesis, the left count, which basically declares how many left parentheses have you left. So basically, for when we come to this, we will our our string was empty, and we had 2 and 2 for the left and right parentheses, but we chose the left parenthesis, and basically we have to add it first. So in the next call of the helper function, we will have a left parenthesis, and we'll have 1 left parenthesis to use and 2 right parentheses to use. Again, we can use the left parenthesis, so this will be again our left node, and in the next, then we can call the helper function recursively again. And in this case, we will have 2 opening left parentheses, 0 left parentheses to use, and 2 right parentheses. Now, for this case, because we don't have any left parentheses left, we have to use the right parentheses. Now, we have 2 right parentheses, which is larger than 0, so we know that we can use a right parenthesis. So basically, we will use it here. We'll use the right parentheses. So in our next call, we will have 2 left opening brackets, 1 closing bracket, 0 left brackets left, 1 right bracket left. And again, we have 1 that's larger than 0. We don't have any left parentheses left, so we will use the right parenthesis again. And in next call, we will basically have 2 opening brackets and 2 closing brackets, and 0 and 0. And this is our base case. So we can use this string that we have generated to add it to the list of the well-formed parentheses. And then we have to basically backtrack again, because we are returning from the function. We are then backtracking back to the node above. In this case, when we go up, we will come to here, and we see that the only possibility for us is to go down to use the remaining right parenthesis. So there is nothing else for us to do. We still have to go up, and the same goes for this node here. We don't have any left parentheses left, so basically we have to go up again. Now, for this case here, we have a right node because 2 is greater than 1, so we can use this to go to the right node. And in this case, instead of using the left bracket, we will be using a right bracket. So in this case here, we will have the current string will be like this, and we will have 1 and 1. So 1 remaining left bracket and 1 remaining right bracket. Next, again, we will go and create a left node, choosing the left bracket because we have still 1 bracket left here, and then our string will look like this. And because we don't have any left parentheses left, we have to go kind of to the right and use the remaining right parentheses. In this case, we will have the following string and 0 0. So in next case, when we call the the helper function again, we will have the base case, and we will add this string to the list of well-formed parentheses. And when we go up the recursion tree, we will see that there are no other combinations left. We cannot go down anymore in the recursion tree. So our two parentheses, well-formed parentheses we can form is this and also this one. So that's basically it for the example. So we'll start by declaring the list of strings, which will present our final output that we will be returning back from the main function can generate parentheses. And in this result, we will be inserting all the valid, well-performed parentheses. Next, we will call our helper function. We will come to the definition of the signature of the function soon. At the end, we'll just return the result. Now, for the helper function, we are passing the string builder, which will basically be the string that we are generating, the well-formed parentheses that we are generating. We'll pass the total number of the left parentheses left, total number of right parentheses left, which at the initial call are equal to n, and also we'll pass our result so that we can insert any valid, well-performed parentheses that we generate. In our base case, when we have the left and the right both equal to 0, that basically means that we have used all the pairs, and we have a well-performed parenthesis, so we can add it to the result and return go up in the recursion tree. Otherwise, we check if we have any left parentheses left, and if we have, we add it to the current string, to the current parentheses that we are generating, and we call the helper function recursively. Now we are passing the current and right and result as they are, but we have to decrement the left because we used one left parentheses. Now, after we are done, we have to backtrack and remove the last element that we have added to the current string that we are generating. And to do that, we will just use the string builder setLength method to remove the last parenthesis that we have added. Now, in the second case, like a right node in the recursion tree, we will check if we have more right parentheses to use than the left, which basically means that we can have still at the end a well-formed parentheses because we will have the right amount of closing bracket and open bracket, so we can add a right bracket, and we can again call the helper function recursively, but now decrementing the right count, so decrementing the number of right parentheses that we have for the next call. And after we are done, we also do the backtracking and remove the last right parentheses that we have added. Now, the time and space complexity are a bit tricky, and they are described, so we always have a multiplier because we are adding for each of the well-performed parentheses. We will be adding it we will be converting the string builder to the string and adding that to our final list. But the second part is actually called Catalan number, and it describes the time space complexity for this perfectly. But for the interview purpose, we can always get a less restrictive boundary. This is only for the interview purposes. So we can say that it's like 4 to the n times n,